Okay, in this next series of videos, we're going to be looking at word problems. So we'll start off with some basic examples, show you how to set them up and how to solve them, and go through different strategies. In lesson 1.1, we're going to deal with integers. So let's look at a brief review of sets of numbers. Okay, so here I have the set of integers. In the middle we have 0, and then we have to the right we have the positive integers 1, 2, 3, 4, and so on, and to the left we have the negative ones, -1, -2, -3, and so on. Now if I just look at the numbers 1, 2, 3, 4, and so on, we say that that's a set of natural numbers or counting numbers. If I include the 0 and look at 0, 1, 2, 3, 4, and so on, then that's the set of whole numbers. And then of course we can go into rational numbers, irrational numbers, and so forth. But in this case we're focusing on integers. Now the next one, here I have the set of odd integers. So we have to the right here, on the right 1, 3, 5, 7, and so on. And then we have on the left, to the left, -1, -3, -5, -7, and so on. So you can see that the difference between any two consecutive odd integers is 2. Okay, 3 subtract 1, for example, is 2. 5 subtract 3 is 2. -1 subtract -3 is 2. Okay, so the set of odd integers, the difference of consecutive odd integers is 2. So in other words, if I add 2 to any odd integer, I get the next one. And also, going back to the first one, if I look at the integers as a whole, the difference between any two is 1, right? 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. -2 minus a -3 is 1. Okay, so these are consecutive integers. So consecutive integers, any two consecutive integers, the difference will be 1. So in other words, if I add 1 to one integer, I get the next one. Okay, so consecutive integers differ by 1. Any two consecutive integers differ by 1. Any two odd integers, the difference is 2. And the same sort of thing with the even integers. Okay, so over here I have -4, -2, 0, 2, 4, 6. Okay, so if I take the difference of any two consecutive even integers, the difference is 2. So if I add 2 to any even integer, I get the next even integer, and so on. Okay, so brief review. So now let's look at some word problems dealing with these. Solve each of the following examples. Okay, so the first one says the sum of 3 consecutive integers. Okay, so consecutive, like 1, 2, 3, 4, 5, okay, they're consecutive, is 123. Find the 3 integers. Okay, so we're going to be dealing with equations in this lesson with one variable. So in solving word problems, the main thing is to know what they're asking you for. So if you don't know what a consecutive integer is, there's no way you're going to solve the problem. So you have to understand in this case what a sum is. That's addition. Consecutive integers, so we just went over that. And then we want to find the integers. Okay. Now I want to point out that you can solve a lot of these problems, especially the types that I'm going to go over in the first few lessons here, without setting up an equation. Just a trial and error and just using some basic strategies. But normally in a math class, your instructor is going to want you to set up an equation, sometimes involving one variable, sometimes involving 2 or more variables. So we start off then by saying, okay, I'm looking for 3 integers, 3 consecutive integers, so I let x equal to the first integer. So I let x equal to the first integer. So I know that if I add 1 to that one, I get the next one. Okay, so I add 1 to the x, I get x plus 1. If I add 1 to that, I get the next one. So x plus 1 gives me x plus 2. So x plus 1, and x plus 2 represent the 3 integers. So now this is where the equation comes into play then. So that means then if I add these up, it says the sum, so that's addition. So x, that's the first one, plus, okay, then I add the second integer, that's x plus 1. And then the third one is x plus 2. And according to the problem, the sum of these three is 123. So I put this is equal to 123. And that's your equation. So then it's just a matter of solving this equation. So combining terms, I have 3x's. So if I add those together, I get 3x. Okay, the numbers, I got 1 and 2 on the left side, so that's 3. And that should equal to 123. And then I want to solve this, so I subtract 3 from both sides. So if I subtract 3 from the left side, that'll just leave me with 3x. And if I subtract 3 from the right side, 123 subtract 3 is 120. So I get 3x is equal to 120. Okay, I want to solve for x, so I isolate the x. So in order to get rid of that x, I have to divide both sides by 3. So 3x divided by 3, the 3's would cancel out and would give me just x. Okay, divide 3 into 120, that's going to give me 40. Okay, so that tells me that x is 40, and what does x represent? That's the first integer. Okay, so this would mean then that the first integer is 40. And if I add 1 to that, I get the next one, so that's 41. And if I add 1 to that, I get the next one, which is 42. So 40, 41, and 42 are the three integers. Okay. So it's x, and then x plus 1, and then x plus 2, and I get the integers. Now I want to point out that there's different ways to set this up, and like I said, if you wanted to solve this one without setting up an equation, if you're just looking for an answer, you could simply say, well, it's three consecutive integers, so they're fairly close together. If I take the sum and divide by 3, I should get close to at least one of the integers. So 123 divided by 3 is 41. Right? 123 divided by 3 is 41. So if I look at consecutive integers close to 41, so I could start with 41 and 42 and 43 and say, okay, that's not going to work. So then I would go down to 40, 41, and 42, and that'll work. Okay, so you can work the problem that way. But if you want to set up an equation, this is the way you do it. Now, you could also set it up something like this and say, okay, let's say you want to let x represent the third integer. Okay, so let's say I put an x here and say x represents the third integer. Then the second integer would be one less than that because it comes before it and they're consecutive. So this would be x minus 1. And then the first integer would be one less than that, so that would be x minus 2. We would have it. Okay. And then I would just do the same thing over here, except now this would just be x minus 1, and x minus 2, and it works out. I would get x if I were to solve. If I would make those substitutions there and solve for x, I would get x to be 42, and then I subtract 1 and 1 each time to get the other two. Okay, and that's your solution to this one. Okay, in the next example, this one says the sum of 5 consecutive odd integers is 445. The sum of 5 consecutive odd integers is 445. Find the 5 integers. So again, as I mentioned before, the difference between consecutive odd integers between any two is 2. So I could set it up similarly and say, okay, let x be the first integer. then 2 more than that would give me the next one because they're odd. 2 more than that would give me the next one, so that's x plus 4 then would be the third integer. 2 more than that would give me the next one. X plus 6 would be the fourth integer. And x plus 8, 2 more than x plus 6 would give me x plus 8. And there you have it. Okay. Now, this would be the same sort of thing if it mentions consecutive even integers. So if you're looking with even integers, the same thing would work. You let x be the first integer, and then the next one would be 2 more than that. The next one would be 2 more than that, and so on. And then you would solve this equation. Okay, so just to save some time here, this thing would be x, and then plus x plus 2, plus x plus 4, plus x plus 6, plus x plus 8, and that supposedly is equal to 445. Okay. So that's what you would write out. Okay, that would be your equation. Okay, so just adding these up and then setting that equal to 445. But just to save me some time, I'm just going to leave it in. So, okay, then you would just add the left side. So I got x, 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 x. I got 5 x's, so that would give me 5x. Add it together. And then I would add the numbers. So it's 2 plus 4 plus 6. That's 12, and 8 is 20. That is supposed to equal to 445. Okay, and now we subtract 20 from both sides, so I get 5x, and subtract 20 from 20, that gives me 0, and subtract 20 from 445. That gives me 225. Divide both sides by 5. And I'm sorry, this is a 4 here. Okay, so subtract 20 from that. This will be 425. And then I divide both sides by 5. So the 5 into the 5 is 1, so this is just give me 1x or x. And then 5 over here is going to give me 85. 425 divided by 5 is 85. Okay, so x is equal to 85, but remember x is the first integer. Okay, so that tells me then that the first integer is 85. And then we add 2 to that to get the next one. So the next one is 87. And add 2 to that, we get 89. Add 2 to that, we get 91. Add 2 to that, we get 93. And of course you can always test your answer. You add these up, add these odd integers up, and that should give you 445. Okay, and like I said before, if this was talking about even consecutive integers, then you could set it up the same way. X plus 2, x plus 4, x plus 6, as many integers as you had, and solve the equation, and you can easily get your solution. Okay, so that's the main strategy. And again, this one again, you could figure it out by taking this and dividing this out by 5. Okay, and get an integer. Since they're consecutive, they're fairly close together, so you can kind of figure out which ones you're going to try, and it'd be a trial and error. But this way, with the setup here, there's no trial and error. You just solve that equation, and you can find the integers. Okay, so I'm going to continue with word problems again. I'm going to go from basic ones like these to a little bit more difficult, different strategies. So again, hope this helps you in your math endeavors, and if you have any suggestions on other types of videos, please post them, and as always, please subscribe, and we'll see you in the next video.